Hey, so we're going to be talking about amino acid synthesis, and we're just going to stick with two of the main methods for synthesizing amino acids, and they both just happen to be named after old German chemists because synthesizing amino acids was probably hot stuff back in the mid to late 1800s. And the first method that we're going to be talking about is Gabriel synthesis, named after Sigmund Gabriel. And the second method is called Stryker Synthesis, which is named after Adolf Stryker. So let's start out with Gabriel synthesis first. In Gabriel synthesis, we begin with a molecule of what's called thalidomidmalonic ester. So N-thalidomidmalonic ester is what this molecule is called. And that's kind of a mouthful, so I'm just going to call this THAD. Alrighty, so here's our molecule of what I'm going to call THAD, and this is sort of the foundation upon which we're going to build our alpha amino acid. And so let me draw an alpha amino acid over here to kind of remind us, what our end product or end goal is going to be. And so remember that an amino acid has first the amino group, and I'm going to draw it in the protonated form. And then we have our alpha carbon, and then the R group or side chain is over here. And then bound to the alpha carbon is the hydrogen and a carboxylic acid group. So if we come back over to our molecule of THAD over here, we can see that the nitrogen atom is going to serve as our amino group. And then we have our alpha carbon here in the center. And then our carboxylic acid here is on the bottom. And then we have this temporary ester group at the top. So I'm going to highlight those key atoms for you here, the nitrogen and the alpha carbon and then the carbonyl carbon. And the reason why we start out with all of these other groups attached to our key atoms is for various reasons. For example, our amide is prevented or quote, protected from acting as a nucleophile by having this phthalimide group attached to it. And then the carboxylic acid is protected with this ethyl ester that's attached. And the alpha carbon is further activated by this additional ester group at the top. Now, in the presence of a base and having a source of an alkyl group, our molecule of THAD will become alkylated to look like this. So now you can see that the alkyl group here has been substituted onto the carbon atom, and so this is known as the alkylated step. And then the next step involves acid hydrolysis, which yields this molecule. And as you can see here, the thalidomide group was hydrolyzed along with the two esters, and this is the hydrolyzed step. And then finally, we can add a little heat to decarboxylate this molecule or remove this carboxyl group up top here, and we get our final alpha amino acid. Okay, so this is Gabriel synthesis in a nutshell. So you start out with an N-thalidomidmalonic ester, and then you add a base and a source of an alkyl group, and you get an alkylated amidomalonic acid here. And then you hydrolyze this to get your carboxylic acid group as well as your amino group. Then you add a little heat for decarboxylation, and you wind up with the final amino acid that's produced here. And so now that we have Gabriel synthesis down, let's move on to Stryker synthesis here. So let's make a little room for that. So next we have Stryker synthesis. And the Stryker method is considered to be a somewhat more elegant way of synthesizing amino acids because it's really a lot more simple and efficient. And just remember that simplicity is elegant. And there are just three starting components, and these are ammonia, which serves as the precursor for our amino group, potassium cyanide, which serves as the precursor for the carboxylic acid group, and then either an aldehyde or a ketone, which serves as the scaffold on which the amino and carboxylic acid groups will be bound. And this provides the carbon that will become our alpha carbon. So let's take an aldehyde and react it with ammonia in the presence of an acid. This will give us an amine as well as a molecule of water. And then the amine can be protonated again in the presence of an acid, and this time a cyanide ion will attack the protonated amine, which generates an alpha aminonitrile. And then finally, the hydrolysis of this alpha aminonitrile yields an alpha amino acid. And so there you have it, Stryker synthesis. You can see how it's a very simple and efficient and therefore elegant way of synthesizing amino acids.